Hey, and welcome to 24 Hours of Past Summit Preview. We're excited you could join us today for Kathi's session, SQL Server Data Compression. This 24 Hours of Past consists of 24 consecutive live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the sessions, after the event. You can find them on 24hoursofpast.com. My name is Christian. I'm a deep stack developer, and I'm also the moderator for this week. Before we start, I have some introduction slides. It will be swift. Next. Yes, if you need technical assistance, you can write it in the Q&A, and we will try to assist you as good as we can. You can also use the Q&A pane located to the right to ask questions throughout the speak, and I will read them up for the speaker in the end of the session. You will be able to zoom on the presentation by clicking the zoom button found on the top of the presentation window. Please note there will be a short evaluation in the end of the session. Your feedback is highly appreciated, especially by Kathi. Next. I would like to use the opportunity to thank our sponsors, Quest, Melissa, and Nutanix. Without their generous support, 24 Hours of Past would not be possible, and it will definitely not be free of charge. Next. Make sure to visit our homepage, past.org, to explore everything we have to offer for data professionals. You can join local user groups, and you can also join virtual chapters and interest groups. And there's a lot of free online resources through the Learning Center. And make sure to read up on our latest community news in the Connect and newsletter. And something I look very forward to.
Went too fast, I guess. Go ahead.
Oh, it's fine. Next.
Okay.
Yes, something I'm looking very forward to is the PASS Summit this autumn. It's taking place the 31st of October to the 3rd of November. PASS Summit 2017 features over 200 sessions with world-class data experts. It's a perfect place to connect and share and learn from the industry experts around the world. To find out more, visit passsummit.com. Next.
So I'll take it away from here.
Yes, definitely. Go ahead.
Okay, thank you so much.
You're welcome.
Welcome to SQL Server Data Compression. I'm Kathi Kellenberger. I am a member of the PASS community. I'm actually a chair, one of the chairmen of one of the virtual chapters, Women in Technology. I have some books out on Apress that you might be interested in, and I also have some courses on Pluralsight. And in fact, just this week, I completed recording a new course on Pluralsight on compression. So if you want to learn even more about compression, be sure to check that out. Today we will be talking about the reasons why you might want to use data compression. There are two types, row level and page level compression. So we'll take a deeper look at each one of those. And we'll follow that with a demo where I'll show you all the code, the different queries and utilities that there are to help you enable this in your environment. So why use data compression? Well, the first reason is really obvious. Because you want to save some space. Using compression can allow your data to take up less space. That's the #1 reason. There's one of the features with compression make it really attractive if you would like to, for example, compress just certain things. Some archival tables, some archival partitions. So it's very, very flexible. You can compress individual tables, individual indexes, and even down to the partition level. So it might make sense, even if you're not interested in it for your entire database, for just certain tables or partitions or indexes. And here's another thing. I was really concerned about compression when I first heard about it back in 2008, because I thought, you know, I don't want to use something like this because there's always going to be a performance hit when you compress. And I just thought it wasn't worth it for most workloads. But what I really didn't know is that in some situations, it will improve performance, because if you think about it, I/O is generally going to be your bottleneck. And since the data takes up less space, you have less I/O. And also, the pages are copied to the buffer compressed, so they actually also take up less space in memory as well. So often you can get better memory utilization by using compression. So there's certain situations that it could make your performance worse. You'll have to test your workload. I don't really have time in this presentation to go into a lot of the situations, but if you think of something specific, I can probably address a question like that at the end. I've wanted to recommend compression to my customers for years. I really have been excited about this feature, but a lot of times I can't recommend it because up until now, it's only been available in Enterprise Edition. And a lot of my customers are smaller shops and they often are running Standard Edition. But guess what? It's now available in all editions. With a caveat, you must be running SQL Server 2016 SP1. So if you haven't heard the news about this, Microsoft made many of the enterprise-only features available across the board, starting with this service pack. And that's really exciting news. And one of those features is compression. So that's one of the reasons, or actually probably the main reason, I was interested in creating a presentation about this, because a lot of folks who haven't used it before, even though it's been around, haven't considered it, is because they couldn't use it, and now it's within their reach. So let's talk about the different types of compression. There are two different levels. There's row level and page level, and row level is going to be the mildest form. You don't get as much space savings, but it's also less resource intensive. So let's talk about that one first. How the way row level works is it works on a row level, row by row, and what it does is stores fixed width data or fixed width data in the smallest size possible. For example, let's say you have an integer column. That integer column, that I'm going to call it a cell, or each value takes up 4 bytes, whether there's a 0, whether it's the largest integer possible, whether it's a null, that always takes up 4 bytes. What row level compression does is allows the storage to be just to be 0 byte, or could be 0 bytes for a null or a 0, or the smallest possible. So if you're storing a 1, it will only take up 1 byte. So it's going to be the smallest size possible for that particular cell. There is a little bit of overhead added to compression to keep track of it, and I'll actually show you during the demo how you can see that if you look at the internal page structure. But for the most part, that's going to be quite a bit of savings if you've got a column that's really larger than it needs to be. Another component of row level compression is Unicode compression. So Unicode compression stores every character on 2 bytes. And the reason for that, and this is the nchar and nvarchar data types, the reason for that is that many languages have there's more characters than can fit on the old ASCII, on an ASCII set. So they have Unicode. and each character will take up 2 bytes just in case it needs that much. And a lot of times, even English, which doesn't really need Unicode, or then there's some other languages too, don't really need to be stored in Unicode, but a lot of places just automatically use Unicode data types. So with row level compression, it will store the Unicode types on 1 byte per character if possible. It does need a little bit of extra CPU to compress and decompress, and Microsoft recommends about 10% CPU headroom available. Most of the systems I see, I have plenty of CPU, and they have other issues, but usually CPU is not a problem. So that's a good thing. It doesn't take up a lot of resources to maintain this. And here's the ironic thing. If your database is designed very, very well, there's only going to be a small benefit to add compression. And what I mean by a well-designed database here, I mean that you've really fine-tuned those data types. If you have a column that's only going to store numbers 1 through 10, you haven't made it, an int. You've made it a tiny int. So you don't have a lot of character, fixed with character types where you don't really need fixed with. So if you've really designed your data types really well, you may not see a lot of benefit with row level compression. So it's like it's taking up space, or it's like removing the space that wasn't really needed if things were done more optimally. One thing that can happen is that sometimes a row will be too large to fit on a page, and in that case, SQL Server will move a column over to what's called a row overflow page, and there is no compression on those row overflow pages. It doesn't compress those and make everything fit on a page. So you don't ever get compression there. There's a new compress function in SQL Server 2016 that you can use to compress row overflow pages. I'm not going to be covering that in this session, but just keep that in mind. Is something that is an option. And Microsoft does recommend row level compression for most workloads. As long as you are going to see some savings and you have some CPU headroom, Microsoft says this is a good idea to do. Again, you need to test in your own database, your own workload, to make sure that it is really a good idea for you. So this is how it works. I've got a table here that has a few fixed width. It also has a variable length. This column 6 is variable length. And if I store this information in this row, notice that I've got some ones here. One of them stored in an int, one stored in a tiny int. I have some dates, and I have a couple of strings. And this is what it looks like. So this first line here, and you can see the colors match up. The first line, if it was not compressed, it would take up 28 bytes. Notice at the end here, since I have a varchar 8 and 4 letters, I'm only taking up 4 bytes. This 4 at the end is not really part of it. So this is how it looks if it's not compressed. If I compress with row level compression, you'll notice that 1 at the beginning now only takes up 1 byte. Another one that takes up less, let's see, I think there was one that went to, I think we save a couple of bytes on this date time as well. I'm not going to sit here and count them. And this char 8, the char 8 takes up 8, even though I only have 4 letters there. That's those 4 extra spaces that it's filled out. With row level compression, it doesn't store those 4 extra spaces, so it takes up 4. So if I had row level compression, I would be able to go from 28 bytes down to 20. And that's a pretty nice savings, but that's how it works. On Unicode, the other component of row level compression is, here's an example. We have, let's see, we have an in-char and an in-varchar. Obviously, I could have other columns here if I wanted, but this is just to really point out, you know, how it works with these two. So here's two strings, test and hello. And if I take a look at how it looks before it's compressed, it takes up 25 bytes. So every letter takes up 2 bytes. So we take a look at that. You know, so this one, every letter takes up 2 bytes. Plus, since it's fixed width, we also have those extra spaces to fill out to the 8 characters. And then hello is a variable length, so it only takes up 5, and then I got to multiply that by 2 because it's a Unicode. So that's how this one looks, okay? So if we compress it with row level compression, what happens is that now we have it down to 10 bytes. Notice that hello is taking up now just 5. And again, you know, SQL is only going to be able to compress this if I have a language that has, you know, possibly even thousands of different characters. This is, you know, SQL can't do this. So for example, English, this would work. Notice that I have an extra byte here on this one, on test. So when SQL Server has a Unicode string, it expects that it's always going to be an even number of bytes. If it's compressed, it could be even or odd. So what SQL Server does is if it ends up being even, like it would be here for test, SQL Server would add another byte to make it odd. So that's one thing that SQL does to keep track of whether a Unicode is compressed or not, is that if it's even, it's not compressed. If it's odd, it is compressed. So you will see an extra byte thrown in here. All right. So the next type of compression is page level compression. This one starts out with row level compression. So if you implement page level compression, you automatically get row level compression. It's automatically part of it. There are 2 steps to page level compression: column prefix compression and dictionary compression. And I'll go into detail on what those 2 things mean in just a second. Page level compression compresses the leaf level pages only. Row level compression applies to both leaf and non-leaf level. Page level compression is leaf level only. There is a reason for that. As you can imagine, so the page level compression is part of deduplicating the data, and it has to be, there's some more resources involved, especially at the CPU level, to compress and decompress the data. Or I'm not sure if I should say uncompress or decompress. So if I'm looking through the B tree structure and I need to, you know, I want that to go very fast. So that non-leaf level is that B tree structure, the top, you know, where I want to very quickly find the rows. So that's, I believe, is why Microsoft does not apply page level compression to the non-leaf level, because it does not want to take the time to uncompress that part of the index, because that would just slow things down. It does take quite a bit more CPU, so you've got to have a lot of extra CPU available for this. And the way that this works, and I'm not sure if I mentioned it before, I think I did, the page is copied to the buffer compressed, and that is where it's uncompressed. So during that, at that point, and luckily SQL Server will only uncompress the rows that it needs. It's not going to uncompress the entire page, just the rows that it needs for that query. But there is quite a bit of overhead on CPU. And Microsoft recommends this for read mostly workloads. So what this means is, for example, maybe you have a data warehouse that you're adding new rows to the facts and dimension tables, but unless there's a one-off, unless there's something unusual that happens, you don't ever update any rows. And that's, for example, you have those slowly changing dimensions that you just keep adding rows, and unless there is some really bad thing that happens, you don't go back and change. And obviously not all data warehouses are that way. Sometimes you have situations where you do go back and change things. So it's rows where you're not making updates, because what happens is, if you can imagine, so let's say we have a page, and I'm going to go into more detail. As SQL Server adds more rows, it has to reevaluate the deduplication part, and you'll understand why in just a minute. And sometimes it has to recompress. So there's sort of this whole maintenance part of this where it has to keep reevaluating to make sure that that's applied, page level compression is applied correctly as new rows are added, as rows are changed. So we want to cut down on that part of it. And there's also, I don't have a slide on it, but there's also quite a few situations where page level can decrease the performance. If I have time at the end, I'm going to go ahead and talk about some of those, because it looks like I'm going pretty fast. So if, depending on if I have time after the demo, I'll talk about a few of those. All right, so this is how column prefix compression works, which is the first step in page level compression. So row level compression, you work on a row at a time. So the example that I showed you was one row. Here we're looking at one page. Okay, obviously this is simplified compared to what really goes on under the covers, but this will help you understand it. I've got a special thing added to my page. So every page will have this new thing added to the metadata called actually a CD region, a CD array. Okay. Let's see. Oh, I'm going to talk about, actually, I think that should be, yeah, CD array. Okay. And we've got a couple of extra rows up here. So notice I have some columns, and I see some data that's at the beginning, it's repeating. Okay, so I've got ABC repeated several times here. Here I've got KATH repeated several times here. This one, I don't have anything that repeats at the beginning. So what we're looking for here is values that are repeated at the beginning. So SQL Server will find those and find the longest value or the widest value that starts with that repeating pattern. So in this case, it's this ABCDEFG. Over here, it's Catherine. Okay, so what we'll do is pop those up into what's called the anchor row. And actually, I think I made a mistake here. I think this is not called CD array. I think I put the wrong label here. CI, the CI range or CI area. compression index. Now I can't remember what it's called. So I put the wrong thing here, and now I can't remember exactly what it's called. So this is called the anchor row. And when we get to the demo, I'll show you exactly what the CD array is. You have the CD array no matter if you are using dictionary compression or row compression. So that's kind of what threw me when I saw that. So what happens is SQL Server moves those values. Notice that over here, there wasn't anything, so it just left it null, and replaces the value with a null in the data. That's what the documentation says. When I did this, I found that what it did is replaced it with an empty string, not really a null. But I'm just going to go ahead and go along with what the documentation says. And the next step, and then what SQL Server will do, the next step is replace any of the values that have that prefix with this value that looks like this. So in this case, we're replacing 3 letters that match the prefix. It's got to be just, so for example, ABC. Here's ABCD. So this one's got 4. ABCD. This one's got 4. And the second part of this is whatever's left over. So in this case, there's 1 letter left over. Actually, in all of these, there's 1 letter left over. Okay, so SQL Server will go ahead and do that in each column. Even though this is page level compression, at least at this step, we're still talking about looking at the column. All right, so those are all replaced. The next step is what's called dictionary compression. And dictionary compression does look at the entire page, and it looks for duplicate values. So notice I have the word stem here, and I have the word stem here. Those are duplicates in the page. So even though they're not in the same column, those are considered duplicates. And it can find, I believe, up to 255 duplicates. And then what it does is it creates what's called the dictionary array. And the dictionary array is the second part here. And notice that each one of these duplicated values is stored up here. Okay. The next thing that it does is it replaces any values that match something in the dictionary array with what's called a symbol. So in this, which is the index of the array. So in this case, it's 0. In the case of stem, it's 3. So it does that across the entire page. So the interesting thing about this is when it's first compressed, it creates this dictionary array. If rows are added or rows are updated, this dictionary array might become out of date, and SQL Server, and also really even the anchor row could become out of date, maybe not the most optimum. So what SQL will do is, like I said, it will keep track of how many updates are made at that page, and at a certain point, it will recompress. And that does take some resources, obviously. All right, so we're just about to hop over to the demo. And really there's also a wizard that I'll show you that you can use to implement compression on a table by table basis. I will show it to you, but I really don't recommend it unless you just want to look at one table. But instead of doing that, you can use stored procedure and also some DMVs to take a look at this. So there is a stored procedure called SP estimate data compression savings you can use to see if a particular index, table, or partition will benefit, size-wise. Will you save some space? This particular stored procedure is pretty intensive. So don't run it during your busy time on your production system. So you might want to take a copy of your database and move it over to a dev system to run it if you're going to be doing a lot of them. So just be careful there. You can also review the index usage. Remember, it really isn't a great idea to use page level compression on tables that have a lot of updates. So you can use this DMV sysdb index operational stats. It's one of my favorites anyway, because I like to keep track of whether indexes are being used. Maybe they're indexes I don't need anymore. And the way you add compression to an index, I'm going to say an index or a heap. I'm just going to call it a table a heap at this point, because a clustered index is an index, right? You add in your with part data compression equals, and you pick row, page, or none. There's another type of compression called column store. That is worth a session unto itself. So I'm not talking about that, but that's another type of compression you could add here. And if you want to add compression to a partition, you just add this little rebuild partition equals, and then you specify the number. You can also say all here if you add that. So if you're doing a rebuild or you're creating initially, this is the syntax you use. So what I'm going to do is I'm going to switch over to my VM. There he is. Okay. And one thing that I like to do is I like to, every time I have AdventureWorks, which is what I'm using for this demo, I like to run Atom Mechanics Thinking Big scripts to create some bigger tables to work with. So I've done that. And I've also, one of his tables in his scripts is called Big Transaction History. It has 32 million rows. It's a nice size table. But I've also created a couple of extra tables based on that, one with row level compression and one with page level compression. And notice that I've included in my create statement here, I'm not going to create the table now, it would take too long, but I've got that with data compression equals row. And I have with data compression equals page. Now, if you wish to add compression on an existing table or index, use the alter rebuild command. Okay, so if it's a table or a clustered index, or a heap, you can use the alter table. If it's a non-clustered index or a clustered index, you can use alter index rebuild. So clustered index, you have your choice, alter table or alter index would work. But the way you do it is just add that with data compression equals. I'm going to skip that part. That's just where I populated it. If you want to try this out for yourself. So the first thing that I want to take a look at is the size. What are the size differences between these three tables? So I'm just looking here at the primary, or the clustered indexes. Just looking at the clustered indexes. So for the row level compression, I was able to save about 37% over the initial size. The page, I was able to save over half. So I got pretty good savings. So let's take a look at performance. I'm going to go ahead and run the first one with drop clean buffers, and hopefully my VM is warmed up enough. I'm not going to do that on all of these because it took a lot of time, but where you're going to see the benefit here, where you're going to see the performance benefit especially with on selects, is with the cold cache, where that table is not already in cache. And actually you can see, at least in my demo, this particular demo, I saw a little bit worse performance when the entire table was already in the buffer. So I'm using DBCC drop clean buffers. Don't do this on a production system because it will knock everything out of cache. So hopefully it won't take too long. When I practiced this or put this together, it took about 11 seconds on this one. And actually it only took 6 seconds this time. So that wasn't too bad. Did I do my, okay. So I did not put the IO here. But since I'm reading the entire table, obviously that's like the statistics IO would be, you know, depending on the size of the table. So this one actually, this time just took 6 seconds. And I might have even been using a different VM when I put this together. If the next time I run it, since everything's already in the cache, it only took 2 seconds. So where you get the benefit is when you actually have to get the data from disk and read it into the buffer. That's really the benefit. In all cases, you're going to see a hit on CPU. All right, so let's do this one. This was the row level. This other one, this time it only took 6 instead of 11. So let me just change that. Since this seems to be going a little faster than when I practiced it, let me just check and see how long this one takes. It's taking longer. Great. I hate when I lie to you. That time it took 9, so I'm not quite sure why that one went faster this time. When I put my Pluralsight course together, what I did to measure performance is I actually had a loop and like ran the query like 1,000 times, something that didn't cause the grid results to fill up, and measured that way. So there's always, who knows, different things going on. So let's see if we get any better with page. And not sure what will really happen. 6 seconds again. So the idea, again, if you have, and it depends on the system, if you have a system, especially that's not running solid state, and I actually am running solid state here, you know, you will see a bigger benefit than if you're running solid state. So it really depends on the situation. I didn't see, at least this little demo, I didn't see a lot of benefit. All right, so I don't know why I've got this here. That would have been better earlier, so I'm just going to get rid of that. Here's that stored procedure. Again, don't run this on your production system during a busy time because this is memory, or this is resource intensive, because it will actually take some of your data and compress it in TempDB to try to figure out the estimate. So if I'm going to run this, and even here it's taking a little bit to run those. So you can put row, page, or none. Okay, so what it gives you is the number of K that it takes. So you can see here, this is the number of K that it expected, and with page level, even a better benefit. And that's, again, just an estimate. You can also go over and go to a particular table, and we're not going to run, you know, right click and go to, I believe, storage, manage compression. And unless there's a way to do this, I just don't know about, you've got to do this on a table by table basis. And you can come in here and choose which type of compression, click calculate, and it'll give you an estimate. And if you continue through the wizard, you can actually create a script to compress it or schedule it or just run it. And in this case, I've got a script here. So there is a wizard. I don't think it's really that useful. All right. Here's another query. This is from Microsoft's white paper on compression. And this is not going to give a lot of benefit here, but the idea is that it will give you a percentage here of how many updates to a particular table or index. And if there are updates then generally you should not implement page compression there. Okay, so using the information between these two, you can decide on a table by table, index by index basis what you would like to do. All right, so let's take a look at the internals, which is kind of interesting. Let's look at, okay, I rebuild that particular table with row level compression, and I have to run a couple of things here. I have to run this to make sure that the results go to the screen. And I think what I'll do is just skip down to this one, because now it looks like I thought I was going too fast earlier, and now it looks like I'm going to be right on time here. And so I'm going to look at the page, because that one's more interesting. I'm going to use this dbcc ind command to get a page. I'm going to grab this one right here and throw it in. So this will allow me to look at the internals of the page, which is kind of interesting. And all those structures I talked about briefly can be seen here. So let's look at, first of all, the compression info part of the record, and you get one per page. Okay, so this tells you if, let's see. Okay, here's what I was looking for. All right, so sometimes it doesn't make sense to use the dictionary compression. Sometimes it doesn't make sense to use the anchor compression. So these are flags to tell you if it made sense for that particular page. Sometimes it's more work than it's worth it. So it gives you that information. This is, you heard me talk about CD array. That first anchor record, if you remember the anchor record, it actually has a CD array, which looks like this. We won't have time to really go into too much detail. So let me just kind of skip down to the dictionary part. So again, every page has this part at the top, once per page. So you can see over on the side here, some of the information that's in the dictionary. Notice that I've got a bunch of numbers here. Those were actually sizes in that table. Those were like size 40, size 42, size 44, and that was character data, not numeric. Okay, so that's part of this CD array, not CD array, part of that CI record in the top of the dictionary. The colors are also, so this is telling me, I'm not going to read through all of this, but like the colors were repeated multiple times in the page. So SQL Server, remember how I had that dictionary array? It saw that like the color black, blue, and yellow were repeated often throughout the page. So that's part of that dictionary array that I showed you. And let's skip that. And here's a CD array of the first row. I don't really have enough time to go to really in depth here, but I'm going to skip down to the where it's showing you the actual records, which is kind of interesting. Like for example, like this right here, this is telling me it's only taking up 12 bytes, and this is a lot wider than 12 bytes, I believe. Here's an interesting one. This one's only taking up 0 bytes, but yet the value is 500. You know, well, that's probably because, you know, it's either was replaced with that, with one of the dictionary values, something like that. You know, here's one that it's only taking up 1. So because of that dictionary part, it was able to take up less information. So let's see what else might be kind of interesting. Here's an interesting one. It's taking up 0, even though it's got 2 bytes here. So given enough time, we could probably spend, you know, a half hour really digging into this. But I thought it was interesting, and I thought I would be interesting to show. So Christian, I guess if are there any questions?
No questions yet.
No questions yet. Okay, so I will talk a little. No questions yet. All right. I will talk a little bit. No. Okay, I'll talk a little bit about, I don't have a slide for it. Let me go pop back over to the slides. The one thing about page level compression that you need to understand is that if you're using a feature that uses row versioning is not compatible with page level compression. So row versioning means that you have a feature turned on that causes SQL Server to store a copy of the row in TempDB. Generally, that's to improve concurrency. Okay. So what happens is the entire page has to be uncompressed before that row is saved there. So that's going to be a performance hit. So where is this mysterious row versioning used? If you have allow snapshot isolation turned on, if you have read committed snapshot turned on, if you are using always on availability groups read-only secondaries, it's turned on. If you're using online index rebuilds, if you are using triggers. So in triggers, it's that deleted row and inserted row that you can work with inside a trigger. All of those things use row versioning. So you could see a hit in performance, you may not understand why. So keep that in mind. There's also some data types that don't compress well. For example, unique identifier. Those are just not going to compress. You know, you can apply it, but you're not going to see really any benefit.
Okay, we have a question from Dave.
Okay.
How does compression handle plop fields? Does it have any effect?
Okay, so generally it's not going to compress those if those end up on. So if you have like a varchar max column, but which I think that's what you would mean by blob. If that is small enough that it still is on the original page, let's say it's only got 10 characters in it, it will compress. If that, let's say you have, you know, a million, or, well, I don't know, thousands of characters, thousands of, much over 8,000, way over 8,000. So it ends up in a row overflow page. It will not be compressed. Absolutely will not be compressed.
Okay, we have one more for Gennady. Yeah, it's asked, is there new information compressing in inserts?
Is there new information in compressing inserts? I don't quite understand the.
No.
So what will happen? What will happen is that you'll automatically row compress the row. If you have a row that's inserted, I think I know what they're getting at. If maybe they're talking about heaps. So heaps, I didn't bring this up, but if you page compress a heap and you do inserts into it, those new rows will not be page compressed. They will be row compressed. So if you do a bulk insert into a heap, they will be page compressed. So what you have to do, if you have lots of individual regular inserts into a heap that you have page compressed on a regular basis, you should run the alter table command on that heap, kind of like you do regular index maintenance, just add that. That's probably what they were getting at. So if it's a clustered or non-clustered index, you will automatically get page compression on new rows. If it's a heap, it depends on how those rows are inserted.
Okay, we have another one from Greg.
Okay.
Is it true that page compression encompasses row compression?
Yes. If you page compress the row, it automatically row compresses it. I'm sorry, if you page compress the table or index, you automatically get row compression as a first step. Yes.
Okay, and we have another one from Tom.
Okay.
Can you have different compression at partition, such as? Yeah.
Yes. Yes, that's really one of the cool benefits. So let's say you have a partitioned table that has some really old data that you don't hardly ever look at. You might say, hey, let's just go ahead and page compress those partitions, row compress the stuff from last year, and all the new things that we're doing a lot of updates on, we just won't compress that at all. I mean, you could have a strategy like that. Here's a weird thing I kept finding online where it said that you could not do that. You cannot page compress individual compressions unless the indexes were aligned, which means the same compression scheme applied to the non-clustered indexes. But whenever I tried it, at least on SQL Server 2016, it let me do it. So I don't know if something changed. So I did, I only spent so much time researching that question. But yeah, that's definitely one of the benefits of being able to compress individual partitions. Definitely a benefit.
Cool. Yeah, we don't have any questions right now.
Okay. I'm trying to think if there's anything else. Obviously, if you're using in-memory tables, those are already compressed. This doesn't work on that. There are certain, this is only works on non-clustered and clustered indexes and heaps. If you have, for example, an XML index, this doesn't work on it. Trying to think of any other little details I can think of.
Yes, or else we have another question.
Okay.
From Ashish, I hope it's pronounced right. Can updates be applied to compressed data?
Yes, yeah, absolutely. You can update compressed data. If you are updating page compressed, it may not perform as well because of SQL Server is going to reevaluate whether that page needs to be recompressed if you update enough rows. So, but yeah, definitely, there's no restrictions on whether you can update or not.
Okay, I have a great question here actually.
Okay.
Do compression work in Asia?
Does it work in Asia?
Yeah, the SQL database.
Like the continent Asia? What do you mean?
No, Azure, Microsoft Cloud.
Yes.
Sorry.
Yes, there's only like 10 different ways to pronounce that.
Yes.
I thought they were talking about something with Unicode for a minute. No. Okay, so yes, it does work in Azure. Yes.
Okay, we have two last questions. How to find table to recompressed? It's Jenny again.
How to find if the tables? No, I'm sorry.
Yeah, I'm not sure.
How to find if it's compressed already?
When perhaps it's when to discover it needs to be recompressed.
Oh, like for a page or for a heap? I was not able to find that information. I spent some time trying to figure that out, and I did not run across it. Maybe it's out there. So what I would do if you have heaps that are page compressed, maybe just do it once a month or something. I was not able to find that. Now, if you went and looked at every single page internal, you could see whether something was compressed or not. If you looked at every row, you can't do that. So you could look at the current space and maybe decide if it didn't look right, you expected more, but I was not, I was hoping I'd be able to find something, and I was not able to find anything to tell me if a large percentage of rows in a heap were not compressed. I was not able to find that information.
Okay.
Might be out there.
I'm going to bundle two questions in one, and then we have less than a half minute.
Okay.
Can compression work with TDE? And what about performance and performances in general?
What was the first one again? Can it work with?
TDE, transparent data encryption.
Ah, perfect. Yes, yes. Yeah. It's amazing. It works great with TDE. It will you'll see this. I saw when I experimented, I saw the same compression ratio. It was great. And then the other question was what? I don't remember.
The performance. What about performance?
So if you're going to see an improvement in performance on selects if you are IO bound, if IO is your bottleneck, you will see an improvement with performance. If there are situations, especially with page performance, that you will see a decrease in performance. So you have to really test your workload to find out.
Okay. Cool. Unfortunately, I have to draw a line here, okay. But I encourage people to write to you with any more questions. And okay. Then I'll ask people to stay tuned for the next speak, which will be Nico Bauer, who talks about column store indexes. So,
very cool.
Yeah, that's all for this session.
All right. Thank you so much. Thanks, everyone, for attending.
Yeah, thanks.